Hi everyone, welcome to Basic Formal Ontology. I am Obi and is
Yeah,
my
I'm Ian.
co-presenter Ian. So today we'll be going through chapter 4, understanding the principles of the best practice 2 from the Basic Formal Ontology textbook. Today is where we understand the OO of ontology. Like I got you. You know what is why most ontology projects don't fail because the term doesn't understand the domain. They fail because the term cannot agree to what the word means. You look at how ontologies are built today, you look at model looks fine until you try to reuse it or integrate it or reason over it, then everything breaks because your terms are inconsistent, your definition are secular, and your taxonomy is barely a junkie drawer. So in chapter 4, we tell you to stop. We are fixing that today. We are going to go through some of the principles that are going to give you a clear terms on how to make sure your ontology doesn't fail.
So I'll start out by talking about what a controlled vocabulary is. That's going to be one of the uses for our ontology is to be tagging the resources that we have or annotating data that we have. And we want to make sure that we are using the same vocabulary to be describing resources together. If people are using the same preferred labels to tag their data, then everybody can find things. And we might still be talking about synonyms as well. Like if we have let's say we're talking about cars. In the literature, they might mostly talk about things, cars as cars. We might also call them automobiles, or they might also be called vehicles in other places. We can actually embed that into our taxonomy so that, for example, if someone is searching for a resource that we have tagged and they're looking for electric vehicle research, but it's been tagged as a car, it's also going to return the article Advances in Electric Cars. And so preferred terms should be those that already have wide usage within the field. So we'll be looking at like textbooks to get our terminology. We'll be talking to subject matter experts. And that's one of the things that the gene ontology specifically does really well, like had a lot of success. And because a lot of people were using it and they were using the terminology that people liked. And so then more people would use it. So then it was being used more. And this is just like a snowball effect. The more popular a thing is, the better it's going to be actually in this field.
I will add from what Ian has just said that I will start with the quality control. And the reason why I love quality control, why chapter 4 is so like enduring to me, is that if you understand chapter 4 in this book, you can build a very solid ontology. When he talked about the quality control, is how you pick on format terms, how you write your definition, how you organize your taxonomy. Those three key things, those three groups will be one of the best quality control you ever have for your ontology. So, like the naming convention, definition and all, like a hierarchy system that is not secretly nonsense. Yeah, because when you have terms and definitions that are sloppy, your ontology becomes a fancy looking confusion generator. This is one of the things that we have every day. I would say let's start with a term. This sounds very basic, right? If I'm doing like my term and I'm selecting and formatting, it's not because the term is the entry point that we have to everything for our data tagging, our query, our integration, our documentation, right? You can have something called Tingy 01 final virtue 7. What does that mean? It doesn't mean anything to anybody until we have the appropriate like name to it or the abbreviation or weird casing or like have that injection. People save things differently. People name things differently. Ian can, for his next homework, can write Ian homework 2 and submit it, while I will write homework 2 OB and submit it. We submitted the same homework, but we have in because we have no defined term on how to submit the homework, we have intent just created our own. And if we are to build that as an ontology, we have chaos because the ontology is just like, what are you guys doing? There's no naming convention. You guys are not defining the clear terms, are not tagging it and integrating this as you go along. So we have to push forward in the discipline and choose terms that are clear and stable. We have to avoid ambiguity labeling, like the example I just gave, where Ian is putting his name first, the homework before he submits, where I'm putting the homework before my name and submitting. And we have to like be consistent in like um the naming schema and not tripping over it. Like we have to be consistent in doing this and having that labeling so that we keep talking together. We don't like uh we don't like walk around each other. If I say oh, you're going to Buffalo next week and you're gonna be at the Buffalo airport, you already know where that is. That's a stationary place. You're going to be going through the freeway, probably get on, is there I-95 down there? I-95 or 85 towards Buffalo. You will understand what I'm talking about. But if we didn't have this naming convention that an airport is a stationary place, the streets are like stationary, we won't be in the same view. You just be like, I'll be like, you're gonna land somewhere and you're gonna take some dusty back road and you're gonna get lost pretty easily. So I think um navigation becomes a very consistent instead of a guessing game, which is why I actually like this. And you get to like something like I can say I'm going to Main Street where I spell main and street separate, and somebody else will spell main and street the same thing, and main underscore street is something else, and main with Maine streets is because when you say main Maine, it's kind of pronounced the same way or referencing the same street. So now we remove that ambiguity by having that layered in our um synonym. So when somebody is looking for Main Street, we know they're looking for this particular street, and we can then give them that street and integrate that, starting to look like our ontologies coming together. We're no longer confusing ourselves, and we're able to like clearly define terms. Yeah.
Yeah, thanks, Obi. You mentioned specificity when we're choosing terms, and that there are some naming conventions when we're talking about stuff. And I just want to mention a few of those. Out of the book, we have used singular nouns, and that one is just to avoid some basic issues that might arise and for some consistency in the ontology creation. So, for example, say we're making like a social science ontology and we want to talk about political systems and social sciences and behavioral disciplines. And then we want to model communism in our ontology, and we say communism is a political systems, or political systems is a social sciences. So this kind of starts to not make sense. And if we just have everything be singular nouns, that way everybody's who's creating an ontology. And remember, these are a bunch of ontologies that are being created that are all based off of this one upper ontology, BFO. And so we want to make sure that all of the conventions are going to be the same across all of the ontologies. And that's just a really simple way to enforce some consistency there. Another term or another principle that we want to think about is ensuring univocity of terms and relations. And univocity means that every term and relationship in an ontology should have exactly one meaning. So let's say we're talking about cell, cell. There's a bunch of different kinds of cells. We could have like a biological cell, we could have a prison cell, we could have a cell in a spreadsheet. And if an ontology used cell to mean all three of these things in the ontology, it would violate univocity and the ontology really wouldn't be very useful. The better approach is just to say biological cell or prison cell or spreadsheet cell as our term. So we can designate which kind of cell it is right in the term. And then we also want to avoid mass nouns. So there are count nouns and there are mass nouns. Count nouns refer to universals whose instances can be counted. So for example, if we have a cat or a dog or a tomato, and we can have 10 cats and we can have 15 dogs and we can have 325 tomatoes. But then we have mass nouns, on the other hand, which refer to an indefinite amount of stuff. So, for example, like water or milk or meat. And here the core problem is actually pretty simple. The mass nouns are ambiguous in ways that decrease the ontology's usability and the clarity in the ontology as well. So, for example, we want to ask our ontology, how many water did our patient drink? Like that really doesn't make sense. But there's a really easy way to fix it. We can take a mass noun and actually translate it into a count noun by adding something just like a portion of to the beginning of the mass noun. So then we have a portion of water, a portion of milk, a portion of meat. How many portions of water did our patient drink? Like now our question makes sense. So it's a pretty easy fix actually also. Yeah, so those are some, I think, naming conventions in BFO as well. Obi.
I love you talking about naming convention because this actually now brings out the way like the authors give very specific anchor about everything in genuine differentiation style. Basically starting with a broader parent and then having a category that is sub like a B and then adding making a differential like a C. So like A is a thing that does some stuff that is a type of B and is distinguished from C. You use water as your example and then had a portion of water, right? I am going to go the total opposite because in my line of work, I'm just going to use something really close to home so that I can break this down. You can see that like the when he defined water, which is like something you can't differentiate. You can have seawater, coconut water, vitamin water. You need something very concrete. And this is where you test the definition of the clear terms that you're using. And while you're doing it, you need to have like uh, water can have a parent and there can be a differential. And sometimes something wrong happen, you either have the wrong parents or the term or don't understand the domain. So this brings us to the good versus the bad, right? You could have a good definition and a bad definition. I'll go with the bad definition first. A bad definition is a satellite that is that orbits. That is secular, right? I'll repeat this. A satellite is a satellite that orbits. You can clearly tell that like by the time you start putting your definitions in, there's going to be a problem. A better ways to do this would be a satellite is an orbital object designed to perform functions such as communication, observation, and navigation. Now you have a clear definition for what a satellite is, right? It's no longer just taking the bare what a satellite is, it's giving it that very well-defined meaning for your use case, right? So you have like orbital object is the parent idea. So now I know, okay, it's an orbital object and it's designed to do perform a function, right? That's the differentiation there. Like it's either doing communication, it's doing navigation or observing some kind of stuff. Now, now that we have that classification, we can compare it and we can reason with it, right? But if you had something that just like X in your ontology without giving the appropriate definition, we'll get into the circular problem. And I think this list will lead us to the classification and taxonomy bucket, and I will leave this to the end.
Yeah, I think so. Yeah, I think I'll just add to that a couple things. I mean, you were talking about the like differentiating the two terms from each other. So, for
Yeah.
example, that a satellite is an orbital object that does XYZ also.
Yes.
And so what we're doing there is we're saying that we have a thing that is a thing that does something else than these other things. So, like we can say a liver is an organ that produces bile. We can say a heart is an organ that pumps blood through the circulatory system, and or like a neuron is a cell that transmits electrochemical signals, and a red blood cell is a cell that carries oxygen through the bloodstream. So we can use this very simple definition to make sure that our definitions are really clear. um, and then we also want to make sure that we're using essential features when we're defining terms. And so to find the essential features of something, we can imagine like an example about like a typical example of something. So let's think about a chair. And then think about all of the instances or all of the things that we would think about that chair, and then mentally remove or change some. And then we can ask, would this still count as that kind of thing if we're removing it? So, for example, let's look at our chair. A chair, it has four legs, it has a seat, it has a backrest, and it's used for sitting. So we can kind of break this down. Now we can say, we can actually like test this against this model. So uh, let's remove the four legs from our description. Would this still count as that kind of a thing? Well, yeah, a chair can have three legs, or a chair can have a pedestal base. So it is still a chair. So four legs is not essential to our definition of a chair. Let's say we remove backrest. Well, a stool doesn't have a backrest, but it might still count as a seat and maybe a chair. So I think we would probably say like that's not essential also. But let's take out a surface for sitting. Well, then it can't really function as a chair, and we would say that the seat surface is actually essential to our definition of something as a chair.
Mm. So now from what Ian just broke down is where the beautiful part of classification comes in, right? You have things where you are having hierarchy, like does the platform where you're sitting, the chair, like you have to make that a corresponding to the reality, and does it support the inference? Inference was where he said if we remove the four legs, it's still a chair. That's the inference. And things like this is why I love why we use Ise like a doctic. Ise is something I think a lot of industry already use. We use it in programming. Um, and when you use it, you start to like understand the whole ontology depends on is a backbone. It makes sense and connects taxonomy, quality to define definitions, and those good definition help you verify your taxonomy, and a good taxonomy makes definition easier and clearer. And this is one of the things that helps. But taxonomy isn't a navigation menu, it's a logical structure. And I want people to like be able to I want you to be able to understand that like because it's a logical structure, you need to know that the structure is wrong or the structure is right. And you can get contradictions, weird modeling, ghosts that haunts every downstream of your system. This is one of the reasons why LLMs hallucinate. So this is a very core of what we do today in our industry for things like ChatGPT that everybody uses. Because if you have good taxonomy and good logic in it, you wouldn't have these ghost problems. And while I was going through this chapter, I realized that, oh, this is why some of my models just crap out of me. And I'm like, I messed up somewhere. I have to go back to my taxonomy now and look at what am I doing wrong, right? And like this drew me back into like giving an example of a reward project that I'm building an enterprise platform, and I started listing out the services that I need, like a service, an application, the capability of the system itself, and the interface, right? And then I had to come up with like clear terms, consistent naming, no duplicate, no false synonyms. And I had to go back and define each terms and make sure the parent is very clear and the differentiator is very clear. And then when I was done with that, I went back to do my taxonomy check and see if service is on that system, then my definition better make that coherent. Otherwise, I just picked the wrong parent. And this is one of the things where you start to see how it integrates because your terms are aligning and not just debating vibes. They just align the structure and you can see how clear it is. So I can say I am a son of my parent, a son of my dad, and he can say that's my son, and I can say I'm the son of my uncle. And that is what taxonomy checks help us to do in this very instant.
Yeah, that's great, Obi. I think the last thing that I would say is just that taxonomy should only have one parent. So if we're checking against the is a relationship, is that every term in the ontology, it has to appear somewhere in that hierarchy and be connected to the root through a chain of is-a relationships, which is what Obi was talking about there. But if we have, our hierarchy has more than one inheritance, it's gonna confuse some of the like computing stuff, and it's gonna mess up our recipe for using Aristotelian definitions also. So it makes our checking our hierarchy harder. Um, and then when we do adhere to single inheritance, it allows the total ontology structure to be managed more effectively. So it reduces a lot of the confusion. Yeah.
I would say lastly that like this chapter taught me to stop being casual. Um, if you want your ontology that people can trust, reuse, integrate, you need to start being disciplined with the terms and practice with it. Have a rigorous definition using a parent and a differentiator approach, which I learned in this chapter to make sure my definitions now include that differentiation approach. Before I just define things using the dictionary terms, but now I'm gonna like define it and then make sure there's that differentiator approach because it helps the next person coming behind me to be able to reuse this. And then I'm gonna make sure that my taxonomy were defined written itself, acting like a quality check. So that way when I go and translate, I don't get interoperability issues by declaring it. I'll enter it through precision, right? And then I can get deeper into using it and having fun with my containers and actually being ready to use my terms, my definition, that wouldn't be a mess. So I think this helps a lot.
Yeah. Agreed. Cool. Yeah, well, I don't have anything else to add.
If you have more stuff to add or questions, you can put it in the comments and we'll do our best to respond. Thanks, everyone.
Yeah, thanks
I
everyone. We'll see you next time for chapter 5.
thank you.